Assalamu alaikum wa rahmatullahi wa barakatuh. This is Mr. Yasser Abdullah. Dear Middle 3 students, today, inshallah, we are going to talk about the catalyst, which is one of the most important factors that affect the rate of chemical reaction. What is meant by catalyst? Catalyst, it is the substance that can be added to a chemical reaction to increase the rate of a reaction without getting consumed in the reaction. What does it mean? It means if you want to increase the rate of chemical reaction, you can add a small amount of a chemical substance called catalyst. This substance will not participate in the chemical reaction and it will not consumed during the chemical reaction. It means it will not change by the end of the reaction. This substance is called catalyst. It's called what? Catalyst. So, what is meant by catalyst? It is the substance that can be added to a chemical reaction to increase the rate of a reaction without getting consumed, without being consumed. It means the mass of the catalyst before and after the reaction will remain the same. And it will not participate in the chemical reaction. It means it's not considered as a reactant or product. Actually, we have two types of catalyst. Positive catalyst and the negative catalyst, which we call it inhibitor. What is the positive catalyst? Positive catalyst, it is the chemical substance that speeds up the reaction. That's why it's called positive. What about the negative catalyst or the inhibitor? It is the substance that slows down the reaction. So, we have two types of catalyst, positive catalyst and negative catalyst. Positive catalyst, it is the substance that can be added to a chemical reaction to increase the rate of the chemical reaction. The negative catalyst or the inhibitor, it is the substance that can be added to a chemical reaction to slow down or to decrease the rate of chemical reaction. How does the catalyst perform its own job in any chemical reaction? How does it work? What is the mechanism of the catalyst? To understand how the catalyst performs its own job, we have to talk about something called the activation energy. What is meant by the activation energy, guys? The activation energy is the minimum amount of energy needed to start the reaction. So the activation energy is the minimum amount of energy needed to start the reaction. Regardless if the reaction is exothermic or endothermic, as you are going to study later, any chemical reaction needs a small quantity of energy to start. For example, if we have a reaction A plus B gives AB. If we wanted to represent the energy graph of this reaction, so here is the energy of the reactants A plus B. And we want to convert the reactants A and B into AB, which is the product. Regardless if the amount of product less or more than the amount of energy in the reactance, the reaction needs at the beginning a small amount of energy to form what? To form the products, which is AB. So this amount of energy, so if this is 100 joule for example, and this is 150 joule for example, so the activation energy here equal 50 joule. It means for this chemical reaction to happen, it needs at least 50 joule for the reaction to start. But when we add a catalyst, what will happen? It will be like that. It means the reaction now will need smaller amount of energy. Say it is just 25 joule to start the reaction, and that of course will decrease the amount of energy needed to start the reaction. So most of the molecules will have sufficient energy to start the reaction. According to what? According to the collision theory. What is the collision theory, guys? I said the collision theory states that for any chemical reaction to take place, the molecules of reactants must collide with enough energy in correct direction. So when we add catalyst, so the energy needed to start the reaction, which is called the activation energy, will decrease. It means the probability of successful collision between the molecules of reactants will increase to form what? To form the products. To form what? The products. So, how does the catalyst perform its own job in any chemical reaction? The catalyst decreases the activation energy needed to start the reaction. Therefore, the molecules of reactants will have sufficient energy to start the reaction, so the reaction will become fast. One of the most examples which we have to study is the decomposition of hydrogen peroxide. By the way, hydrogen peroxide, it is H2O2. This chemical substance, which is hydrogen peroxide or the oxygen water, decomposes alone into what? Into H2O plus O2. As you can see, the equation is not balanced. If we wanted to balance the equation, so we have to add here 2 and here 2. So 4 hydrogen enters the reaction, 4 hydrogen comes out from the reaction. 4 oxygen enter the reaction, 4 oxygen come out from the reaction, so the equation now is balanced. This decomposition of hydrogen peroxide needs a long period of time. So, if you want to speed or to increase the rate of the decomposition of hydrogen peroxide, you have to add catalyst. In this case, the catalyst is manganese dioxide, MnO2. When we add small amount of manganese dioxide, the hydrogen peroxide will decomposes fast into water and oxygen. Water and what? Oxygen. And the oxygen gas evolves up, as you can see. So, what is the role of manganese dioxide here? Manganese dioxide here acts as a catalyst. It used to increase the decomposition of hydrogen peroxide into water and oxygen. So here manganese dioxide is considered positive catalyst. What if we don't have manganese dioxide? What if we don't have any chemical substances to speed up the decomposition of hydrogen peroxide into water and oxygen? We can replace manganese dioxide using a slice of sweet potato. It will play the same role as manganese dioxide. And this will take us to another term, which is the enzyme. What is meant by the enzyme, guys? An enzyme is a chemical substance that is produced inside the bodies of living organisms. Like what? Like the sweet potato, for example, or inside our bodies. Acts as a catalyst, so its role is to speed the rate of chemical reaction as well. But the reactions which take inside the bodies of living organisms are called biological reactions. By the way, the word enzyme is equivalent to what? To catalyst. The only difference is the enzyme is produced inside the bodies of living organisms. So, when we add a slice of sweet potato on hydrogen peroxide, the reaction rate will increase and the decomposition will be fast, because sweet potatoes has enzyme which act as what? Act as catalyst. By the way, the enzyme which exists inside the sweet potatoes, it called the oxidase enzyme. Called what? The oxidase enzyme. So again, what is meant by the catalyst, guys? We said a catalyst is the substance that can be added to a chemical reaction to increase the rate of a reaction without getting consumed in the reaction, without participating in the reaction. And we said the types of catalyst, we have two types of catalyst, positive catalyst and negative catalyst. Positive catalyst speed up the reaction. Negative catalyst slows down the reaction. And we said the catalyst increases the rate of chemical reaction by decreasing the activation energy needed to start the reaction. What is meant by the activation energy? It is the minimum amount of energy needed to start the reaction. For example, if we have a reaction A plus B gives A, B. A and B at the beginning, they have certain amount of energy equal 100 joule. And for A and B to react, their molecules must collide. And for this collision to become successful, it needs 50 joule. So 50 joule is called the activation energy. If the molecules of A and B have such amount of energy, so the reaction will happen and it will become fast. But what if the molecules of A and B don't have the sufficient energy to start the reaction, which is 50 joule? In this case, we have to add what? We have to add catalyst. In this case, the catalyst will decrease the amount of energy needed to start the reaction from 50 joule, for example, into what? Into 25 joule. In this case, most of the molecules of A and B will collide with enough energy, so the reaction will become fast, or the rate of chemical reaction will increase. Example of the catalyst, the decomposition of hydrogen peroxide into water and oxygen. If we wanted to increase the rate of decomposition of hydrogen peroxide into water and oxygen, we have to add catalyst. In this case, the catalyst is manganese dioxide. Please don't mix between manganese dioxide and magnesium oxide. There is a big difference between manganese and magnesium. Here, manganese dioxide will act as positive catalyst. What if we don't have manganese dioxide to speed the rate of this reaction? We can take a slice of sweet potato. Sweet potato has oxidase enzyme which act as a catalyst which will speed up the decomposition of hydrogen peroxide into water and oxygen as well. But here, this is called enzyme. An enzyme is what? Is a chemical substance that is produced inside the bodies of living organisms. Acts as a catalyst to increase the biological reactions, What are the main properties of catalyst, or the main characteristics of catalyst? Number one, the catalyst speeds up the rate of chemical reactions. Yeah, this is the main function of any catalyst, any positive catalyst. Number two, it decreases the amount of energy needed to start the reaction, which is called the activation energy. Number three, it doesn't participate in the reaction. It means it just increases the rate of chemical reaction, but it will not behave as a reactant or product. It will not change before and after the reaction. Number four, its mass before and after the reaction remains constant. Of course, as it doesn't participate in the reaction, so its mass will not change. Its mass will remain constant. So, if we have a graph like that, here is the concentration in mole per liter, and here is the time in second. One, two, 3, 4, and 5. Here, 1 and 2 are the reactants. Why? Because their concentration decreases during the reaction. 3 and 4 are products as their concentration increases during the reaction. But what has constant concentration and doesn't change? Number 5. So number 5 is the catalyst. 5. It can be used in small quantities and can be used several times. Number 6, it combines with the molecules of the reactants and separated once the products are formed. So as you can see, there are 6 characteristics of any catalyst. Number 1, the catalyst speed up the rate of any chemical reaction. Number 2, it decreases the amount of energy needed to start the reaction, which is called the activation energy. It doesn't participate in the reaction. Its mass before and after the reaction remains constant. And as you can see from this concentration time graph, 1 and 2 represent the reactants, 3 and 4 represent the product, number 5 represent the catalyst. As you can see, its concentration doesn't change before and after, and even during the reaction itself. Number 5, it can be used in small quantities. It means I can use just 1 gram, 2 grams from any catalyst, and it will play the same role and it will have the same effect on the reaction, and I can use the same amount for several times for different chemical reactions. Number 6, it combines with the molecules of the reactants and is separated once the products are formed. It means it makes the collision between the molecules of reactants easier, and once they collide with enough energy in correct direction, the catalyst will be separated and leaving them to react together, forming the product. It means it has nothing to do with the reaction itself, except it increases the rate of the reaction. We all know that all the cars use the gasoline to get the energy needed to operate the car or to run the car. During the burning of the gasoline will produces harmful gases like carbon monoxide and nitrogen oxides. These gases are very, very harmful gases, as carbon monoxide will combine with the hemoglobin of the blood instead of oxygen, and that will cause death. And also nitrogen oxides are dangerous gases because they cause many diseases like cancer. So we cannot allow such gases to be exhausted to the air. So we have to use what's so-called catalytic converter. What is the catalytic converter? It consists of an insulated chamber, contains a ceramic cells like the B cells. You know, the shape of the B cells, it's like that. It's like that. But why it has such a shape? Just to increase the surface area of the reaction. And these ceramic cells are covered with a thin layer of catalytic metal or catalyst as platinum or iridium. These two metals will behave as catalyst, so they will increase the rate of the conversion of these harmful gases into what? Into normal gases exist already in the atmosphere. What is the function of the catalytic converter? It used in cars to change the harmful gases resulted from the combustion of the gasoline, like carbon monoxide and nitrogen oxide, into normal gases exist in the air. It means carbon monoxide will be converted into carbon dioxide and water vapor, and the nitrogen oxide will be converted into nitrogen and oxygen, and such gases already exist in the normal atmospheric air. The B cell's shape is to increase the surface area, so the conversion of the harmful gases takes place faster. And at the same time, the platinum or iridium will behave as catalyst, so they will increase the rate of the conversion of such harmful gases into normal gases. And this is the end of lesson 2. So, choose the best answer. During the chemical reaction, the concentration of reactants what? While the concentration of products what? Respectively. It means in order. Increases, 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 decreases, remains constant, increases, decreases, increases. Yes, good. The correct answer is D. Why D, guys? We said before, during the chemical reaction, the concentration of the reactants decreases gradually. Why? Because they are consuming. We consume the reactants. And at the same time, the concentration of products increases because when the reactants are consumed, they are consumed to produce, to increase the concentration of what? Product. So the answer is decreases, increases. Question number 2, 1. In the opposite graph, determine the reactant or the reactants. Graph line or lines. It means you might choose one graph line or more than one graph line. So, one only is not a reactant. This is product. Why product? Because its concentration increases with the time. 2 only. Yes, 2 is a reactant because the concentration decreases with the time. But it's not only 2 because 3 as well is what? 3 as well is a reactant because its concentration decreases with the time. So the correct answer is what? 2 and 3. The answer is D. The second part of question 2, which generic equation represented the opposite reaction? This is a reaction. So which equation can be represent such graph? AB gives A plus B. It means we have one reactants and two products. Sure, it's wrong because we have two reactants and one product. AB plus CD gives AD plus CB. It means we have two reactants and two products, but we have just 3 graph lines. So B as well is wrong. A plus B gives the AB. Yes, A plus B gives the AB. We have 2 reactants and 1 product. So most probably this is the correct answer, but we have to check the last one as well. A plus CD gives the AB plus C. It means, guys, 2 reactants, 2 product. So this also is wrong. So the correct answer is C. So guys, by this question, we have done the chemistry unit. In this unit, we studied 2 lessons. Lesson number 1 was talking about the chemical reactions. Lesson number 2 was talking about the rate of chemical reactions. We said the chemical reaction is a process in which bonds in reactants are broken and the new bonds in products are formed. And we said any chemical reaction can be represented by chemical equation. This equation must be balanced. It means the number of atoms enter the reaction must equal the number of atoms come out from the reaction, because matter is neither created nor destroyed. We divided the chemical reaction into 3 types: thermal decomposition reaction, substitution reaction, redox reaction, which is oxidation and reduction. In thermal decomposition reaction, a substance decomposes into its element or similar substances by heat. And we studied 5 reactions, if you remember: the decomposition of red mercuric oxide, the decomposition of copper carbonate, copper sulfate, copper hydroxide, and the sodium nitrate. Substitution reaction divided into 2 types: simple substitution reaction and the double substitution reaction. In simple substitution reaction, we studied a metal substitutes a hydrogen of water or acid, or metal substitutes another metal. In double substitution reaction, which takes place between the ions of ionic compound, and this is the only chemical reaction which doesn't involve redox reaction because it takes place through the transfer of ions, not the electrons. We divided the double substitution reaction into 3 types. Acid plus alkali gives salt plus water, which is known as neutralization reaction. Acid plus salt gives acid plus salt. Salt plus salt gives salt plus salt. The last type is the redox reaction. And the redox reaction, it is the process in which the electron transfer from one substance to another. The substance from which the electrons are transferred is oxidized, where the substance to which the electrons are transferred is reduced. We studied 2 definitions for oxidation, 2 definitions for reduction, 2 definitions for oxidizing agent, 2 definitions for reducing agent. And we studied 2 reactions. The first one, the dry hydrogen gas passes through hot black copper oxide. It gives water and red copper. And we studied which one of the 2 reactants oxidized and which one reduced. The second is related to the electronic theory, in which we studied the reaction between sodium and chlorine giving sodium chloride. Sodium as a metal loses its outermost energy level electron, so it oxidized. Chlorine is non-metal, so it gains the electron lost from sodium, so it is reduced. Don't forget, the substance which is oxidized is considered reducing agent, and the substance which is reduced is considered oxidizing agent. The rate of chemical reaction, we started the rate of chemical reaction with the meaning of the collision theory, if you remember, the meaning of concentration, the definition of the rate of chemical reaction. We studied the decomposition of dinitrogen pentaoxide into nitrogen dioxide and oxygen, and we said practically in the lab we can determine if the reaction is fast or slow from the disappearance of reactants and the appearance of products. What are the factors affecting the rate of chemical reaction? We have 4 factors affecting the rate of chemical reaction. The nature of reactants, which is divided into the type of bond and the surface area. The temperature, the concentration, and the catalyst. In case of the type of bond, the reaction between ionic compounds is much faster than the reaction between covalent compounds, and we explained why. Surface area, we said the greater the surface area, the faster the chemical reaction. Why? Because when the surface area of the reactants molecule increases, so the probability of successful collision between the reactants molecule will increase, so the rate of chemical reaction will increase. So the reaction between diluted hydrochloric acid and iron, if the iron is powder, so the reaction will be faster if it is just one piece of iron. Both of them will react because iron is more active than the hydrogen of acid, but the iron powder will